Good morning, folks. I'd like to thank you for joining us this morning. We're going to talk about some of the advantages and some of the products we can use for fall applications. I'm going to start though with a safety moment. And as we get closer to the busy fall season, we may still be in our summer mindset of our driving and the complacency of driving during daylight hours. Since our days are shorter, you may get in your vehicles with good daylight and visibility, but will soon be driving in the dark. So take the time to check your mirrors so you aren't adjusting while on the road, and be prepared for the evening fatigue that is more noticeable when it gets dark. There's going to be a lot more trucks on the road and a lot more animals that are moving across the road, especially as you harvest and you lose some of that cover for them. So just drive safe, and thanks for joining us. To start with, we got Dr. Alan Blaylock. He's a senior agronomist with Nutrien, and myself, I'm Kent Broscoff, living in Minnesota, covering some of the upper Midwest here. And with that, Doc, if you want to take it.
Yes, thanks, Kent. So again, welcome to everyone here today. I'm Dr. Alan Blaylock, senior agronomist with Nutrien. Many of you, we may have talked in the past or interacted previously. Just a few reminders about this session. We will be recording this webinar. It will be posted on the websites for these products, smartnitrogen.com and smartnutritionmst.com. I'll put those website addresses up at the end of the presentation. So they will be recorded for later viewing. CEU credits are available for attending this webinar, and we will post the QR code for those of you that use the app on your phones. We'll put that up on the screen at the end so that you can capture that and register if you use the app. So with that, let's get started into this discussion about fall nitrogen applications. So I'm sure many of you are familiar with what we call the 4R nutrient strategy or nutrient management, and there's an illustration of this on the screen. Today we are going to be focusing on timing, and particularly related to fall, but recognize that when we change the timing, we may also need to change the source, change the place, even the rate. So these don't necessarily change independently, but we are going to focus on timing and particularly fall application today and some of the implications of that. So the challenge with fall applications is that in many regions, we know that they are more risky. There's more risk of nitrogen loss, and that means economic loss, environmental risk with the use of fall applications. And so the way I like to look at this is there are kind of two basic risks, nitrogen loss risks. One is when we apply urea on the surface, and the risk of loss there is volatilization if it's not incorporated within a fairly short time. That's a short-term risk. That risk occurs within a few days to maybe a week or 10 days after application. And once the urea is converted to ammonium, then that risk is past. So those losses occur within a short time after the application, and there are ways we can manage that. The other risk, and this becomes probably more important for the fall applications, and that's the risk of having nitrate present in the soil. Now, we know that nitrate is needed for crops. Plants take up nitrate very quickly. We can supply a lot of nitrogen to the crop in a short time in the nitrate form. But anytime nitrate is in the soil, it can be lost by leaching or denitrification with excess water. And so this is a season-long risk. Anytime the nitrate is present and we have conditions for loss from rainfall or irrigation events, then that nitrate can be lost. So this is of special concern for fall applications because the nitrogen is sitting in the soil for quite a long time for most crops. And so that means risk. And so we want to talk a little bit about what that means. So here's a really brief illustration of the nitrogen cycle as it pertains to fertilizer applications. And you can see the potential losses highlighted in red, potential volatilization from ammonia, potential denitrification or leaching from the nitrate form. And typically we don't have both leaching and denitrification at the same time, but it could happen. Denitrification occurs when the soil stays wet for a period of time, even a few days. Leaching occurs when water is moving down through the soil. And nitrate forms by a process we call nitrification. So that's going to be important to our discussion today. When we apply virtually any of these forms, virtually all the fertilizers we use today contain some form of ammonium, or as in the case of urea, something that converts to ammonium, and that ammonium then converts to nitrate. In warm soils, this is very quick. In cold soils, it's very slow. So that plays into our discussion of fall application. So we're going to be talking more about that. But just keep these processes in mind, because these processes govern our risk of loss. Here's another form of volatilization that's not from urea. Those of you who've run an anhydrous rig have probably seen this from time to time. And when we don't have proper soil conditions, the soil's either too wet and the slot doesn't close, or it's too dry and we don't have moisture to trap the ammonia, or we're not applying deep enough. So misapplication or improper soil conditions can result in this loss. And you've seen this when you lift the rig out of the ground and the ammonia remaining in the lines escapes. Well, this is water condensing on that cold ammonia vapor. And so that's what we see there. And it's an indication of nitrogen loss. And so that's dollars going up in the air. So we want to prevent that. One of the important things to keep in mind for fall applications is the rate of nitrification. And this is kind of a standardized, idealized relationship you'll find in many textbooks. The point here is that in warm soils, nitrification goes very quickly. So you can see at 75 degrees, it's virtually complete in about a week's time if there's moisture present. On the other hand, at 35 degrees or at 50 degrees, when the soil is cold, that nitrification goes much slower. So if we put fertilizer out in the fall and the soil freezes and stays frozen, that nitrification is very, very slow. And so it keeps it in the ammonium form until the soil warms again. So that's important in terms of our management. Our timing of that fall application is really, really important. We'll talk a bit more about that. So we want to pay attention to these soil temperatures in relation to our management. Now, obviously, there are places where the soil doesn't really cool off. And in those cases, it may not be appropriate to apply nitrogen in the fall. So we want to be aware of the conditions and the risk. And there are two things that go into that risk. One is that temperature and the rate of conversion to nitrate, and the other, of course, is the rainfall or precipitation, the driver of those loss mechanisms. So just something that may be of interest, and this is just a sample, but I think it's characteristic of much of the Midwestern US. This is actually from Minnesota, but it shows that our winter temperatures have been getting warmer, particularly in the last couple decades. And you can see those temperatures rising. That means greater nitrification over winter, and so more risk of N loss. Now, we also couple that with precipitation. So this, again, is from Minnesota. And you can see that over the decades, the rainfall has increased. So with the combination of increasing winter soil temperatures and more rapid nitrification, and we couple that with greater rainfall, that means more risk for that nitrate in the soil. So this is something that we should be aware of in planning our fall nitrogen applications. Now, I should also say that much of what we say about nitrogen also applies to sulfur. Its reactions are similar. There are some of the same biological transformations, the conversion to sulfate sulfur, the mineralization of sulfur from the soil goes to the sulfate form. And that sulfate form is mobile in the soil like nitrate. So it can also be lost by these same processes. So a lot of what we say about nitrate is true for sulfate. Now, one of the interesting things that's come out in recent years, a study done in Montana on volatilization losses in cold temperatures, and indicating that our risk of volatilization over winter is greater than we have maybe previously thought. We often say, well, if it's cold, we don't have so much volatilization. But there are some examples in this study where there were particular cases where there was high volatilization losses in cold conditions. And these were specifically related to the conditions in which the urea was broadcast, the amount of moisture that was present, and the amount of precipitation that came after that application. So you can see here, this actually in March, it's not in winter, but here's one applied in November without urease inhibitor, almost 32% loss. Here's another one in February, 44% loss, one in October and January. So what the study has demonstrated is that maybe some of our conventional thinking about urea application and volatilization and cold temperatures didn't apply, and that the risk for volatilization may be greater in cold conditions than we have thought. So how does that implicate, or how does that apply to our management? Well, that means we really probably should be incorporating the nitrogen where possible and not leaving it on the surface over winter. Here's one specific example from that study. This is one that was listed there. And you can see that there was no rain in 2 weeks, and we said that that's the period where volatilization primarily occurs. And then after that, there was 1.5 inches of rain. And so you see these high volatilization rates in the first couple of weeks, and then it declines to near zero after that. But it's all a function of the lack of rain immediately following application. All right, so let's wrap up this with a few points, and then we'll move into some products that we think can help with these fall applications. So it looks like we have a hand raised from our participant here. Go ahead, Troy. Troy, are you muted?
Sorry, I think I hit it by accident.
Oh, okay. All right, so you didn't have a question?
No, not this
no worries,
time.
no worries. Okay, you can go back on mute. All right, so we certainly want to be sure that we understand that fall nitrogen application is not always a good practice, and there are many areas where it's certainly not recommended. So briefly, there are certainly many complications of this, but just briefly, we could say that temperatures that are too warm to stop nitrification. So if that biological activity continues through the winter and nitrogen is going to be converted to nitrate, and we have potential for loss, we have precipitation that is sufficient to cause loss, we really shouldn't be applying nitrogen in the fall. Now, you know, all of us most of us on here are agronomists. We've had experience in the field, and we really should recognize that this is a risky application. Now, that said, there are situations where fall nitrogen is acceptable. Those environments where we can minimize the losses, either we have less rainfall, we have some management practice we can use to minimize that loss, such as applying in cold temperatures and cold environments. A crop that can use Much of the nitrogen that we apply in the fall, we'll get into a couple examples, but for example, forage grasses are fairly aggressive nitrogen feeders in the fall, and if we can get nitrogen to them, it's often beneficial. But we don't want to exceed what the crop can use in that time. So certainly we want to be upfront about this and say, look, fall nitrogen or fall sulfur is not a good practice for everyone. There are places where it fits and there are places where it doesn't. And so we want to be aware of those conditions that contribute to the losses and recognize the risks involved with that. So don't take this presentation as a recommendation to everybody, oh, let's run out and apply nitrogen in the fall. For those where nitrogen can be used and may be an acceptable practice, then there are some guidelines that we can follow. We talked about the timing. Timing is critical. Apply the nitrogen late after the soils have cooled off. And for those of you that use anhydrous ammonia, that 50-degree temperature has been a guideline for years. And obviously that can cut into your window. And we look at this year with potentially early harvest and people wanting to get in the field. There's going to be the temptation to get out and get the work done. And so we really want to be careful about when we're applying the nitrogen and not succumb to that temptation if the temperatures are not appropriate. Broadcast nitrogen should be incorporated wherever possible to reduce the risk of runoff, the risk of volatilization, and those losses. We should never be applying fertilizers on frozen soil. That increases the risk of runoff and loss of nutrients into waterways, and that's a particular problem for late application. We shouldn't be applying nitrogen or sulfur in the fall on sandy soils. There's just so much risk there. It's not a very efficient practice, and there's lots of data that shows poor agronomic performance and increased environmental risk. If we are going to apply a urea form, some treatment of that urea has been shown to be better, a nitrification inhibitor to keep it in the ammonium form longer. And based on the data that's been accumulated in the Midwestern states, we could say, generally speaking, the best sources for fall application are ammonia with a nitrification inhibitor and ESN, which we'll be talking about here. So those are just kind of some general guidelines. There's obviously a lot more to that, but just reemphasizing that we pay particular attention to the conditions, what we're doing, when we're doing it, in order to get the best performance of that fall nitrogen. And if it's not appropriate to put it on in the fall, let's wait till spring. Let's do a pre-plant or let's do split applications. We can also, I think Kent is going to talk a bit more about this later, but we can apply, maybe reduce the amount we put on in the fall to reduce that risk and put some on in the spring or as a top or side dress later on. So there are some things we can do to reduce the risk of fall applications where fall applications may be acceptable. Okay, so I'm going to hand it back to my colleague Kent Broscoff to discuss a couple of products that may have a fit in enhancing the efficiency of fall applied nitrogen and sulfur.
Yeah, thanks, Doc. I just thought I'd remind you guys that there is a spot where you can type in some questions and we'll get through as many as we can at the end. Some of you guys also submitted some questions in advance, so I'll go through that when we're done with our presentation. What I'm going to do is introduce a couple of products that some of you guys have probably used or heard of, and maybe you haven't. Kind of just an introduction, so you can see what they are and how they might fit in what you're trying to do. First one is ESN, which is environmentally smart nitrogen. It's a polymer coated urea where we actually take a urea granule and we apply a polymer coating over that. And what happens is water will go through the polymer coating, dissolve the urea within there, and then the nitrogen is released by diffusion from a high concentration to a low concentration of nitrogen in the soil. So that's how it moves to the soil. It because it's going to happen over a very long period of time, we have less concerns about volatility or leaching, denitrification, some of those things. And when it comes to a fall application, once the soils are frozen, there's not free moisture moving around. So the nitrogen is going to be locked inside that polymer and waiting for warmer temperatures in the spring to start release. Can you hit the next slide, please? Doc? This is a photo. Yes, this is a Topdress application, but what we're trying to do to show it's not catastrophic release of the urea granule. The granule itself does not break down to release the nitrogen. If you see the photo on the left, you've got various stages of release and various amounts of urea dissolved within the polymer coating. And if you actually dug those out of the soil and you rolled it between your fingers, it's going to feel like a 28% kind of that slimy, sticky as it's releasing the nitrogen. So basically that's what we're trying to do here with this photo, is just to show that it's not all catastrophic release. Go ahead to the next slide. So release is driven by temperature. What this is actually a water bath where from second one, it's at a constant temperature. So what you're seeing here is at 41 degrees, for example, at 126 days of a constant 41 degrees, we've released just over 20% of the nitrogen available in each of those individual granules, versus at a soil temperature or water temperature of 86 degrees, you can see that the release is much faster, again, which is just showing that temperature controls the release. Yes, we have to have some water to hydrate that urea granule within the polymer coating, but it is temperature that's driving the release. The next slide, please. The next product that I'm gonna touch on here, and Doc will get into more details, some of the yield data and all that, is our MAP+MST, which I'll refer to as MST. Each granule is the 943O with 16S. So each granule, it's a homogeneous granular product. Every granule will contain that analysis. Go ahead to the next slide, please. So, a lot of guys, and I've done it in the past, we blended our fertilizer, our P and K in the fall when we're adding the sulfur and all that kind of stuff. What you see in the middle slide is our MAP+MST. It's, again, MAP where we put the micronized sulfur. MST stands for micronized sulfur technology. We infuse each of those granules. And if you look to the picture on the right, that's actually the white spots is the sulfur within the granule. So our distribution is very thorough throughout that individual granule. And again, every granule contains that same analysis. Go ahead, next slide. So what is MST? Like I said, MST is micronized sulfur technology. It's the very small particle size. It's the smallest particle size in the industry right now. Our particle size is in that 10 to 15 micron size. A grain of sand is about 75 microns. So we're a very small particle size, and particle size is what determines how long it takes before the sulfur is available to your crop. Like I said, we put MST in the MAP as we're making MAP. So every granule, you could see the consistency of the granules, the small size, and it's a uniform distribution in each granule. You got a good surface area because you got a full-size granule, and then each the surface area of every individual compound of the small size sulfur. It's 15% of that sulfur is going to be in the elemental form, and 1 to 2% of that is in the sulfate form. Okay, next slide, please. We all know that elemental sulfur has got to be oxidized to sulfate before the plant can utilize it. So what we're showing here is particle size, how long it takes before the plant can take it up. So if you look at, like I said, MST is in that 15-ish size micron particle size. At a particle size of less than 60 microns, in 2 to 4 weeks, you're going to have 80% of your sulfur released from that in a normal soil warming conditions, not something over winter. Obviously, over winter, the soils are cold, so you're not going to be having this oxidation take place. But during your normal spring and summer weather, we can release that sulfur over a relatively short period of time, but it's not all available the same day. Okay, go ahead. Next slide. So when you consider putting sulfur application in the fall, you need to know, most crops show some type of advantage to applying sulfur. Corn, alfalfa, beans, all those have some sulfur requirement. Remembering that soil type is important. The higher the organic matter, the more sulfur you have naturally in your soils. So low organic matter, sulfur is going to be very important to apply. The other thing to keep in mind is with the passage of the Clean Air Act back in, I believe it was the mid 80s, we're not getting that free sulfur deposits anymore. So that's why the popularity of sulfur has been exponential growth in that, because we've been shorting our crops for sulfur for a long time because we're not getting it free from the air anymore. As far as the sulfur source, remember that sulfate is leachable just like nitrogen is or can be. So applying a product like AMS in the fall, there's a good chance you might be leaching a bunch of that sulfur through the soil profile, meaning it's not available to your crop. Or if you apply your sulfur too early in the spring, you could have potentially the same problem. As far as past results, weather impacts the sulfur availability. Like I said, if it's sulfate, it can leach. If you are applying an elemental sulfur, your typical 90%, very large particle size, it's going to take a long period of time for that to release some sulfur for your crop. And you just need to know what your sulfur requirements are for the crops and soils that you have. Next slide, please. So like I said, the average particle size is at 10 to 15 microns, means that we have a lot quicker sulfur oxidation, a quicker availability to the crop, but it's not all available on day one. So as your crop, you don't need all your sulfur on day one either. So it's a better opportunity for sulfur to be around later on in the season. Less risk of sulfur leaching, because it's going to be tied up, not oxidized, so you can't lose it. It's a product that very firm product, so your bulk blending will be good with your P and K and nitrogen and those things that you're usually doing. It doesn't, I've seen a number of samples of this product and stuff that's been in a bin for quite a while, and it seems to take very little moisture up, so the flowability has always been pretty good. And again, the slow release keeps sulfur available throughout the growing season. Next slide, please. I will turn it over now to back to Doc so he can go through some of the yields and some of the individual data points that we have on this. Go ahead.
Thanks, Kent. So the next section, we're going to talk about a few examples from some of our research with the MST and ESN products, particularly focusing on fall applications, and to validate where these work well and what kind of results we've been getting. So this is an example from some of our recent research. It's a combination of a number of trials across the Corn Belt, Indiana, Iowa, Minnesota, Wisconsin, over the last couple of years. And because it's a new product, we don't certainly have the volume of data that we have for ESN that's been on the market for a while. But when we look at this, we can see there's really, in this particular case, averaged over these studies, there's not a lot of difference between fall and spring. There's a few bushels here. It wouldn't be statistically significant, but But the other thing we can see, and this goes to some of the questions that came in from registrants, participants of this webinar, asking about is that sulfur going to be available for the crop? Is it going to oxidize fast enough? And I think from these yields we can see that it was at least as good as AMS, ammonium sulfate. So when we look at that, we have a little bit greater yields for both fall and spring applications of the MST than we had for the ammonium sulfate. So that's an encouraging sign. There's always a concern. That's the question people always ask with elemental sulfur is, will it oxidize fast enough? And here's a good example that, yes, indeed, it's supplying available sulfur at least as well as ammonium sulfate. So in one homogeneous product, you get your phosphate and the sulfur together. So that's an encouraging set of studies here in that regard. And so I hope to those who are asking that kind of question, hope that helps you understand that. All right, so one of the things we want to talk about, so we're going to switch to ESN and some of the results. This is I'll call it growth chamber simulation in soil, and what this graph is showing. So Kent showed the temperature relationship with ESN release and how that controls the temperature. In this particular example, in this incubation, we started at a temperature of 50 degrees and we cooled to freezing. So this is somewhat of a simulation of a fall application in cold conditions. This was run at two different moisture contents, 50 and 70% of field capacity. So first we see that the moisture really didn't affect the release rate at all. And what we see with this decreasing temperature, you can see there, yes, there was some release over this 75-day period at these temperatures, but that release is fairly small. We're just over 20% total release after 77 days. And then at this point, the soil would freeze and that release would stop until things thaw out again. So that's that gives us a little bit of information about how ESN is going to behave with that fall application following our normal guidelines to wait till the soil is cold, 50 degrees or lower before we apply our nitrogen in the fall. So we're following the same guidelines and making the same recommendations for ESN that many of you have used for the application of anhydrous ammonia. Here's another way of looking at that. So the green and the blue lines are the same temperature lines from the graph that Kent showed earlier for 50 and 68 degrees Fahrenheit. So that's the release of ESN. When we compare that to nitrification rates, so these are the temperature curves or lines from the earlier graph I showed with nitrification. So if we were to apply, for example, urea, and it's going to nitrify faster at that same temperature than ESN. So the one we would compare is this 50-degree line for ESN and the red line for the nitrification. So showing that ESN can indeed reduce the risk of loss and nitrate exposure over that same period of time. So I'm just looking at a few questions that have come up here. And I think this would be a good time to address some of these. One question that is showing here is, I've heard that the polymer coating freezes over winter and breaks apart. Is this true? So Kent showed you the release mechanism. That release is by diffusion. The coating stays intact. And even when the soil freezes, keep in mind that urea solution inside, if the urea has not yet dissolved, it's a solid, so nothing's going to happen. If that saturated urea solution inside has developed, the coating is somewhat elastic, and we have no evidence that it freezes and breaks. And we've taken pictures in the spring following a fall application to see that coating still intact. So no, we don't see any evidence of that. A couple questions here on applying MST on corn in the fall. Can I get enough nitrogen for growth. And I think the figure that I showed just a moment ago shows that indeed MST is supplying sufficient sulfur to meet the crop demands. Should I apply AMS with MST in the fall and winter wheat? This is a really good question. And so keep in mind that temperature is a factor in sulfur oxidation, and time is important. So if you're applying it in the fall on winter wheat, keep in mind wheat is going to need some of those nutrients, nitrogen, phosphorus, sulfur, in the fall to drive tillering and get the crop established. So applying a little bit of ammonium sulfate with that could ensure early availability, maybe perhaps 25% of the total sulfur as ammonium sulfate, with the balance as the MST would be a good ratio to get enough sulfur just to get the crop started, and then relying on the MST for the next season. All right, so let's go on to some of the actual experimental data, the research data that we've seen. This is a study out of Iowa that that was done by Dr. Randy Killorn a number of years ago. So it's an average of 4 site years, and it's shown in 2 different ways, same data. If we look at ammonia in the fall without a treatment of any kind, you can see that it does not perform as well. And these site years did have nitrogen loss conditions. Comparing ESN in the fall, we're some 24 bushels better from that fall application. Now, we can also see that, yes, spring was a little bit better. Probably not statistically significant, but spring application of ESN was better. Spring application of ammonia was definitely better. But the fall application of ESN was quite similar to a spring application of ammonia. So that's that protection that we're getting from the controlled release nature of the product. One of the application methods that we have seen really works well for ESN is to band it in the soil. This is a study from Waseca, Minnesota. Dr. Giles Randall. This is an average of 5 site years there at Waseca. And in this case, we have ammonia with N-serve, and a banded ESN. So keep in mind when we compare ammonia to other nitrogen applications, we're often looking at ammonia as a band, which it would always be, versus some of the other applications of broadcast. In this case, the ESN was banded so that we had the same placement, and there was a small advantage for ESN over ammonia in the fall. So for those who maybe don't want to handle ammonia, banding has been a great way to apply that in the fall. And I think I've got another example with a strip till application where it also looks very good compared to ammonia. Here's another study. This is some more recent data that Dr. Fabian Fernandez has been accumulating. He's been doing a lot of work with nitrogen sources and timing and all these different applications. And here's an example where we see that what this illustrates is clearly fall urea broadcast did not perform very well. Even using the nitrification inhibitor was a little better, but still not as good as ammonia or ESN. For the ammonia with N-serve, it performed similar fall and spring. The ESN was maybe not quite as good in the fall, but still much better than urea. So if your needs dictate a dry product, ESN would certainly be a better choice for fall application. And then in the spring, those two were similar, but still better than the urea applications. And again, keep in mind the difference here. This is a broadcast application where the ammonia is a band. So there could be some disadvantage there to the broadcast application. Looks like we've got a few more questions here. So a question about how much nitrogen is left over from ESN after application in the fall. Now, I think I'm guessing that this means from the fall going into spring, how much of the ESN remains. So that's maybe a little hard to answer exactly, but if we put it on late and it's cold, ESN will still be intact in the spring as the soil starts to thaw and warm up. And then as temperatures increase, it will start releasing nitrogen. So we're putting it on late, there's going to be very little release in the fall, and most of the release will come in the spring later on. And you can think back to the graph I showed with the temperature relationships, how that plays out. So most of the nitrogen is still inside the coating as we go into the winter. Here's a question about MAP+MST and MES and how they differ. They are similar products. They're made in a similar way. It's a homogeneous fertilizer. They both include sulfur in the granulation. The analysis is a little bit different. The MST has a higher sulfur content and a higher total nutrient content, so that's an advantage in that you haul less material. The biggest difference between the two is the size of the sulfur, the micronized sulfur in MST versus the MES. And I should also note that in the MES product, a part of the sulfur is ammonium sulfate, roughly half ammonium sulfate and half elemental sulfur. So there are some differences. They're manufactured in a similar way, but yes, there are some basic differences. Okay, let's go on to another study. This is a recent study out of North Dakota looking at fall application of ESN for spring wheat. Now, again, keeping in mind that the appropriate management practices, if we are going to put nitrogen on in the fall, and in eastern North Dakota, where these studies were done, sometimes wet soils in the spring are a problem and you can't get into the field. And so there could be some justification for fall applications if done properly. So in this study, we have urea, we have ESN in the dark green, which is straight ESN, and then we have a 50-50 ESN urea blend in the light green. Now, one thing that jumps out at you immediately is that the October application is not quite as good. Even with ESN, it's a bit too early and doesn't perform as well, and particularly for urea. This site is a little bit, soil's a little bit on the lighter side, sandy loam soil, so there's a little bit more potential for nitrogen loss here. But if we look at this November application, it's much better than October, certainly for the urea. And that November application of straight ESN is actually pretty similar to our spring applications. And if we're going to go with the spring application, that blend was our, at least numerically, our best performing treatment, even versus a split urea and UAN application. So this gives us some information about how to manage those applications, fall versus spring, the timing of that fall application, and what works the best. This was an average of 4 site years, if I remember correctly. Okay, let's look at another example. This is a strip till study. This is done in Northeast Missouri, and these soils are particularly problematic because they're clay pan soils, and a little bit of precipitation causes pretty large denitrification losses because they tend to pond. And in this case, we have ammonia, ammonia with N-serve, ESN, and urea, and these are all strip till applications, comparing a November application versus March application in the spring before planting. And you can certainly see that the ammonia with N-serve and the ESN perform very well. These are good yields for that site in those poorly drained soils. And you really see the advantage of spring application for the urea, but for ESN, ammonia with N-serve, fall and spring, it didn't make as much difference, and the ESN really was the same for fall and spring. So fall strip till, where fall applications are suitable, that strip till application has really performed extremely well in a lot of our studies. So if you have that capability, that's a really great way to apply ESN. And it simplifies the operation versus applying ammonia. You can blend your P and K with it in one dry blend, and that has worked out very, very well. Okay, we're going to jump to something a little bit different. This is a study on tall fescue pasture in Missouri. And I mentioned earlier that forage grasses are aggressive nitrogen feeders in the fall. And so they will take up nitrogen if it's available to them, and they store the nitrogen in the roots and in the crowns for that early spring growth. And we've learned a lot about this in the turf sciences as well. A lot of people recommend for cool season turf grasses, the best time to fertilize is early in the fall and get nitrogen into the grass, and it comes back real strong in the spring. That's what we saw in this study in Missouri. And the one thing that surprised me here is that the 100% ESN actually performed the best consistently in this study, and the blends, which I thought would be better, did not do quite as well. So I haven't totally figured that out, but this fall application on pasture with ESN, the end right here was 75 pounds of total nitrogen in these different forms, but applying that early enough in the fall that the grass could take it up. Here's a case where the earlier application was actually better than the November application that was also in the study. So it just didn't become available soon enough applying ESN in November. And consider the difference between a forage grass that's trying to grow roots in the fall and corn, which hasn't even been planted yet. So keep in mind the crop differences dictate our practices here, but this is a very interesting result for us. Okay, let's see. It looks like we maybe have another question here. So what percent of urea and ESN was in each blend? I think maybe if we go back, we have been talking about one of the previous studies. Also in the North Dakota study, maybe that's the one the question is for, that ESN urea blend was 50% of each, 50% of the nitrogen as each. So I think that's the one he's probably referring to. And the blends are shown here on this forage grass study. So hopefully I answered that for you. So anyway, we produced almost a half ton more forage with that fall ESN application than we did with urea. All right, so I'm going to hand it back to Kent for a few minutes to kind of wrap up some of the things that some of our growers and dealers are doing, and some of the different programs for using these things that that may be of interest to those on screen. So Kent, I'll shift it back to you now, and then hopefully we'll try to have a few minutes at the end for some questions.
All right, thanks, Doc. Yeah, just as a reminder, ESN is it's a polymer coating. It's known for delaying the release of nitrogen. I get questions a lot of times about the polymer coating itself, what happens to that over time. It takes about 18-ish months for that polymer coating itself to break down. So you're not going to develop a layer of polymer coating over time, a number of years or whatever. But frozen soils would stop the release process, leaving your nitrogen locked in the coating until warmer soils occur to start your diffusion to your soil. So basically what we're trying to say here is, if you apply it late enough and you incorporate it, you're going to be storing it in very cold soils, just like you're storing it in a bin in a fertilizer plant. Nothing's going to really happen to it because the soils are frozen and you haven't started the diffusion process. A lot of people have historically applied urea, which is open to greater losses, as we've talked about, and ammonia systems, even with nitrification inhibitors, you can still get a bunch of applied loss. If nothing else, you saw that photo that the doc had used earlier in the presentation. Next slide, please. So some of the things to consider when you're talking about fall ESN tactics. All nitrogen products are best applied when soil temperatures are colder to minimize the environmental risk. If you have an environmental risk, if you lose it, that's lost investment dollars. Deep banded or incorporation is recommended. Get it off the surface so you have less issues. ESN applications are much quicker to apply. For you guys that use ammonia, you can get twice as much production in acres done per day using ESN over ammonia. What are your limitations on equipment, and what's your help that you have available that can reduce your capacity to get your jobs done? ESN and MST can be blended with your fall P&K products to eliminate trips and reduce compaction. Lasts longer than even the treated ammonia for greater potential environmental protection. And ESN is listed as a BMP in Minnesota where Fall N is approved. Next slide, please. Continued is use it as a complement or replacement to ammonia. I know there's a number of people that are getting out of ammonia for various reasons. You know, when you look at some of the insurance and all that other kind of stuff, the expense of the toolbar and having all the extra help just to run an ammonia system, that's a reason that some guys are getting out of ammonia completely. If field conditions are not conducive to a good application of ammonia, you know, back in younger days, putting ammonia on, I remember you're pulling like a basketball through the fields. You got corn stalks and soil that are frozen to those knives, and you're just not making a good application. That's not environmentally or economically a good idea. Dry products are not as dependent on soil conditions to seal like ammonia bands, just like we've talked about. Irregular fields, some areas have triangular fields or something like that. And if you're trying to put ammonia on those fields, you got a good chance that you're going to triple apply in certain areas, which is obviously not a good idea. It's lost money and it's not environmentally a good idea. ESN can help make the blend flow easier, especially for your strip till guys. The flowability by having ESN is tremendous. It really makes a difference. And you won't need to wait to apply nitrogen in the spring if you're using some ESN in the fall, which can, in certain years, you have delayed planting and less than stellar timing of nitrogen products in the spring. Go ahead to the next slide. Some guys, where suitable, they apply part of their total nitrogen needed for next year's crop. Following that with a top dress of additional nitrogen or a weed and feed application in the spring, reducing the risk. It also allows them to get some of that workload done in the fall when they probably have a little more time. The plant spring applications could be pushed back because you know you have some nitrogen out there. You're not waiting for someone to come and make an application or for you to do it yourself. And all the fall applications allow time for fertilizer to convert or oxidize to plant available forms, like we talked about the MST. You've got to convert or oxidize that sulfur before it's available, and a fall application would allow time for that to happen. Here's a number of different websites that are available to you. We'll leave that up. I'm going to get into a couple of the questions that have come up or that were sent before. Can I apply enough MAP+MST in the fall to supply all the sulfur corn needs the next spring? Doc? I'll let you take her. I'll read the questions and you can answer. So take yourself off of mute, please.
I was trying to. I couldn't get my. Apologize for that delay there. Yes. So one of the key things with sulfur that we've seen is making sure you get enough out there, particularly with a slow release sulfur form like MST, because it takes a little while to release. If you're a little bit short on the sulfur, then that's going to be an issue. But so make sure you apply enough, and if you put it on in the fall, the data we have seems to suggest that yes, it will apply enough sulfur for the next crop if you have a sufficient rate.
The next question I had is, I guess you could address it with ESN or MST. How much can you put out in the winter and have it still available around tassel?
Yeah, so that's kind of the key intent here, is to be able to put these materials out and have the nutrients supplied later in the growing season than we would from a conventional material. Now, our data would suggest that from a fall application of ESN, that release is going to carry into probably about the end of July, typically. And that obviously is going to vary by conditions, temperature, and all of that. So It's maybe less of a calendar date than a growth stage or weather kind of program, but that is the intent. Now, for those who have longer growing seasons, growing longer mature or later maturing hybrids, perhaps a top dress might be appropriate. And one of the applications that a lot of people are using is a top dress of ESN in a blend, maybe a 50-50 blend at about, say, V4 to V8. Would certainly carry that on further. So if that's a concern and you really have a longer growing season, need to push the nitrogen a bit later, some combination might be best. But in our regions where fall application is appropriate, it has performed fairly well according to our yield data.
What is your recommended amount of sulfur to apply on corn?
Typically on corn, I think the recommendations coming out of our Midwest universities look like about 15 pounds of sulfur. Units of actual sulfur are typically enough in low organic matter soils, particularly where there may be some loss occurring. Maybe 20 pounds might be needed, but I think University of Minnesota is recommending 10 to 15. Some may be 15 to 20, but it's kind of in that range. And looks like for most applications, 15 should be sufficient.
Okay, thank you. So this would relate to both ESN and MST. How much can be safely applied in furrow with wheat?
Yeah, so we have, we're kind of studying that now with the MST because the elemental sulfur has no salt index. It's really MAP in terms of salt index, considering the seed safety. As far as ESN, we have some rate guidelines published on our website, smartnitrogen.com. I'd refer you to that. If you can't find that, go to the Ask the Agronomist link. So I'll mention these links because we're out of time and need to wrap up. But for those who have other questions that we didn't get to, there's a link on both the MST website and the Smart Nitrogen website that I'll put those back up for you. And there's an Ask the Agronomist link there. So if you have questions, you can submit them there and we can give you detailed information and even send you some documents if you can't find what you're looking for. So please consider that as a resource as well. But we have published tables for ESN and seed safe rates based on planter configuration and soil types. And those are based off the Canadian provincial recommendations for safe rates of urea. But our general rule of thumb is 2 to 3 times the safe rate of urea for a given set of conditions. And so if you want to discuss that further, get in touch with us and I'd be happy to have a more detailed conversation about that.